Hello ladies and gentlemen, today we're going to look at graphing straight lines, which involves two special cases and two general methods. First off, we're going to look at the general methods. You've seen them in Year 9, so I'm going to go very quickly. Essentially, to graph an equation of a straight line, the easiest way to do it, if it's in general form, is to use the axis intercept method. So just a reminder, general form looks like this, where you have ax plus by equals a constant, where a and b are whole numbers, or any numbers, fractions, whatever. And essentially what we're doing in this method is we're finding where the line crosses the y-axis, where the line crosses the x-axis, and from there we're going to join those 2 points and draw a line straight between them. Alright, so how do we do this with this specific equation? Well, to find the y-intercept, let x equal 0. So we have 3 lots of 0, which I won't even write, and therefore 4y is equal to 12, y is equal to 3. Similarly, and I'm hoping this is all just recall from Year 9, to find the x-intercept, you let y be 0, therefore you'll have 3x plus 4 lots of nothing is equal to 12, x is equal to 4. So what that means, this point indicates we are crossing at the point y equals 3. And this point, we're crossing at the point x equals 4. And from there, we grab our straight line tool, which I'll inevitably mess up on this thing, and go through those 2 points. That is the graph of this equation here. Now, note how it has arrows on both ends. That indicates it continues on forever. Alright, method 1. Method 2 is called the slope-intercept. We just use the y-intercept and the slope. And this is best used if you have it in y-intercept form, or slope-intercept form rather, where the number, or the coefficient of x, which isn't always first, but usually is first, we know as m is the slope, and this part on the end, usually called c, is the y-intercept. As we know c is the y-intercept, we know it crosses here. And then we use m to start drawing a line. The way I think about m is, you start off from a grounding point, think C, then you run 1. Now m is where your step is. So in this case, it's minus a half. If we run 1, we drop a half. Run 1, drop a half. Run 1, drop a half. If the slope was positive 3, we would run 1, rise 3. Run 1, rise 3, and the line would head up that way. In our case, we're going down this way. So from here, we're going across 1, down a half, across 1, down a half, across 1, down a half. That forms our line to be graphed. The other way of thinking it is rise over run, and both ways will work out just fine. Alright, so 2 ways to graph a line: slope-intercept, axis-intercept methods. Now, there are 2 special cases: horizontal lines and vertical lines. Firstly, consider the case of x equals 7. X equals 7 means that every point along the line, x is equal to 7. The y values may change, but all of those points along this line, x is equal to 7. Similarly, y equals 4. All the points along the line, y is equal to 4, and we can draw a line going this way. Alright, so it's best to remember that these 2 forms here are for vertical lines and horizontal lines. Now, you've seen all of that from Year 9, so what you haven't seen from Year 9 is how to do it on your CAS calculator. So let's open up CAS, press B, and you'll get a graph. Now that's your Cartesian plane. It only goes from 10 to minus 10, 6.343 down to negative 6.43. If you want to change, you can use your cursor and double click. Say I want to go out to 20 there. Then I press tab, and it will keep going around the Cartesian plane, letting me choose numbers. I might want to go to minus 20 down here. Tab, I might only want to go minus 5 there. Tab, and 20 here. And that way I can set the portion of the Cartesian plane we're looking at. To actually enter an equation, either double click anywhere on the screen that's free, or just press tab. Now this bit here, f1 of x, is a different type of notation than we're used to. It means it's the first function of x. For our purposes, for now, just consider this entire thing to be y. Think of that as y equals. So say I want to graph the line y equals 2x plus 3, I'd type in y equals 2x plus 3 and hit enter, and that's that line there. Or if I wanted the line minus 7x plus 12, that line there. Now, let's say I want to find exactly where they meet. We'll learn how to do this algebraically later, but for now, the CAS calculator gives us some cool options. We can go Menu, Analyze Graph, Intersection. Now then it asks for something quite strange. It asks for a lower bound and an upper bound. And essentially you have to give it boundaries to where the calculator will search between. Because it's possible later on we'll come across graphs that do this, that might intersect with a straight line hundreds of times. And if you just want to find one intersection, you need to tell it a boundary to look in. So I will look for lower bound there, upper bound here, and they intersect at this point, x equals 1, y equals 5. Cool, huh? Right. Can you, in your OneNote, please plot these two equations of the line on this graph? You may copy that graph across to your personal OneNote if you like. And then, using your CAS calculator, or algebraically if you want, find the exact point where they meet. Thank you very much. I'll see you next lesson.